putting it all together. So you'll start with 3 pieces of the triangle. So like you always have the 90-degree angle, and they'll either be given two side lengths. So you have the 90-degree angle and 2 side lengths. So you have 2 angles to find and 1 side. Or you'll be given the 90-degree angle, a side, and an angle. So you'll just have 1 angle to find, but 2 side measures. So we can use all these helpful things that we've been using with right triangles the last couple weeks. So the Pythagorean theorem. So if you have 2 sides, you can use the Pythagorean theorem, the a squared plus b squared equals c squared, to find the 3rd side. You will have to use SOHCAHTOA at least once, because if you just have 2 side lengths, the only way we can find an angle is by using inverse SOHCAHTOA to find one of those angles that are inside the triangle. If you are given just 1 side and an angle, you have to use SOHCAHTOA to find a 2nd side, because in order to use Pythagorean theorem, you have to have 2 sides. So if you just have 1 side, you have to use SOHCAHTOA to find the 2nd side in order for you to be able to either use SOHCAHTOA again or the Pythagorean theorem. So you will have to use, I'll start SOHCAHTOA. You'll have to use that one at least once. The other 2 we use most of the time. This one is a rule we haven't really discussed yet because we haven't really worried about finding all the angles. But you actually will use the 3rd rule that we can probably every time as well. Because once you have 2 angles, all 3 of them have to add up to 180. So it's just a quick subtraction to find the 3rd one. So instead of having to go through the whole SOHCAHTOA process a couple times to find 2 angles, you can just do it once. And then once you have 2 angles, the 90-degree angle and the one that you find, you just subtract that off from 180 to get the remaining angle, which is what I typically do. So this is just kind of sectioning them off. So if you have not enough sides, the ways you can find sides, if you have 2 sides, you use the Pythagorean theorem. If you only have 1 side, you have to use SOHCAHTOA, just regular SOHCAHTOA. If you need to find angles, like I said, if you have 2 angles, you can find the 3rd one just by using subtraction, because all 3 of them have to add 180. So you take 180 minus 90 minus whatever the other angle is, and figure out what that 3rd angle is. And then if you don't have any angles besides the 90-degree angle, you have to use SOHCAHTOA using inverses to find 1 angle. So I'm just gonna do a couple of examples. I have 4, but I don't know if we'll go through all of them. So on this first one, I said you always start with 3 pieces, and then you'll have to find the 3 pieces that are missing, because there's 3 angles, 3 sides for every triangle. So this time we're given the 90-degree angle, so we only know this angle, and then we know these 2 sides. So then what we need to find is this 3rd side up here that we don't know, and then these 2 angles that are labeled with the capital letter F and the capital letter G. So those are the 2 things we're going to find. I'm actually going to go ahead and put an X there for that side that we're missing, because we're missing that side. That's the only side we're missing. So we have the other 2, and then we're missing the other 2 angles, because the only angle we have right now is the 90-degree angle. So it actually doesn't matter which one you find first. Typically, when I have 2 sides like this, I go ahead and use the Pythagorean theorem. Because if you have 2 sides, you can find the 3rd side by using a squared plus b squared equals c squared. So I'm going to do that quick. So I'm going to find what I've labeled with X first, and then I'll talk about the angles. So which one of these has to be specific? C has to be the hypotenuse, and I do know the hypotenuse. I'll go ahead and label that. Hypotenuse is right here. It's across from the right angle. So the 13 has to go in for C. So then we'll have x squared plus 5 squared equals 13 squared. And then solve it just like we did when we first started doing right triangles. So we have x squared plus 25 equals 169. And then we subtract the 25. So x squared is equal to 144. And we take the square root. That's nice to see on this first example, because what's the square root of 144? 12. Yeah. So we've already found 1 side. Okay. And if you want to, you can label it up here on the triangle now. So now we know all 3 sides. So now we just need to do a little bit of work to find the 2 angles that we have. Because we need to find angle F, because we don't know this angle, and we We also don't know angle G. And it doesn't matter which one you pick to find next, but we will have to use SOHCAHTOA to help us out. Okay? Because if we knew two of the angles, all three of them have to have 180. So we could use that, but since we only know that this is 90, we need to find one of the other two angles in order for us to use that third rule where all angles have 180. So we're going to have to use SOHCAHTOA, and specifically we're going to use inverse SOHCAHTOA like we've been doing last week to find one of those angles. So we want to find angle F or angle G.
Can we do angle H?
H we already know. Is 90.
So, yeah, never that stupid question in my head also.
Do F.
F, yeah.
F. Okay. So the reason why I haven't circled anything yet is now I'm going to label the rest of the triangle based off of the angle that I picked to find first. Right away, it actually doesn't matter which one you find first, the angle F or G, but you have to make sure you really specify which one you're finding, because in order to label the opposite and adjacent sides, you're going to have to make sure you pick the right angle to label that on. Because now we're going to find F, that would make 5 the opposite, because it's across from angle F, and then this 12 that we found the adjacent.
Use the 13 too.
Yep. So the nice thing about finding all three sides first is we know all three sides, and we can actually use any one of the SOHCAHTOA. We can use 12, 5, or 13 to help find the angle. So it's your choice whether you want to use sine, cosine, or tangent to find angle F. So do you want to use sine, cosine, or tangent?
I'm using tangent.
Okay, we'll use tangent. Okay, but specifically we're finding an angle, so we use tangent inverse. And since we picked tangent, we're going to use the opposite and adjacent. So we're going to use the 5 and the 12. But know that you could have picked any one of the other three because we knew the hypotenuse. So we could have picked sine because we have opposite hypotenuse. We could have picked cosine because we have adjacent hypotenuse. Or we could have picked tangent. So like I said, once you know all three sides, to find an angle, you kind of get a little bit of choice. So then I have my calculator. I'm going to do tangent inverse of 5 over 12. So I got 22.6. There's that angle. Again, you don't have to label on the triangle, but sometimes I do so that way you know what I found or what I need to find yet. So the only thing left is G. Now, you could go ahead and do the SOHCAHTOA again for G, just to label the triangle, or what I tend to use is this third rule. The angles have to add up to 180 degrees, because if I already know that this is 90 and this is 22.6, I can just use a little bit of subtraction to find this remaining angle. Does that make sense? So I'm just going to take 180, I'm going to subtract the two angles that I know, and that'll give me angle 2.
So it's just 7.4.
And I found all three of the missing pieces. And I actually used each one of the rules we could, because I used the Pythagorean theorem first, then I used SOHCAHTOA, and then I used that rule where angles add up to 180. So, generally when I set it up, I tend to use all three, just because it tends to be a little easier. Questions about the first one? Like I said, nothing is really new. We're just kind of putting it all together. The only big new thing would be this, but you may have heard that before. So that's the only thing we haven't used yet, but it's an example to use. So that was when we started with two sides. So the only three things we knew were the 90-degree angle. We knew this was 5 and this was 13. So the other possibility on this next triangle is now we start with a 90-degree angle, like normal. We have another angle, so we actually start with two angles this time, but we only have one side. So what's the easiest thing to find first? The other angle, yeah. Because if I already know these two, one's 62, one's 90, again, I can find angle C by just doing a couple quick subtractions. So I'm going to use the rule, and you don't have to write this every single time, but that way if you're looking back at the notes, that makes it, you can think, okay, why did I use that to find that angle, or using the fact that angles add up to 180 degrees. So I'm just going to take 180 minus 90 minus 62, and that'll give me that angle C that I don't know. I'm going to do it in my head, but my subtraction is not very easily. Okay, so we already found that this is angle 28. Tiny triangles, it's hard to do. So now, the things we're needing to find, we have two sides that we're missing. So I'm going to label one side with an X and one side with a Y. So we can't use Pythagorean theorem yet because we need to have two sides in order for that to work. But we can use SOHCAHTOA. Because we have some angles and we have one side, so we can use regular SOHCAHTOA to help find whichever side you want to find next. Okay. So I'm going to pick an angle to use. You actually know either one, so you can use either the 62 or the 28. I tend to like to use the one that was already given to me. So I'm going to circle A because that's going to be how I label my triangle. So now I need to end. I actually only have one side. What's the 10 for my triangle? Hypotenuse, yep. So I know my hypotenuse. So that tells me right away I'm probably going to have to use sine or cosine because I don't have enough information to do tangent because the two sides that I don't know are the opposite and adjacent. Okay? Now because I'm using A, my Y is my opposite because it's across from my A, and then my X that I've labeled, that's my adjacent. Okay? So make sure before you label opposite and adjacent, pick the angle that you're going to use and then don't change your angle. So I'm using angle 62 in my SOHCAHTOA. So that's how I labeled my triangle. So since I picked 62, the side that I labeled with the Y is across from it, so it's the opposite. The side I labeled with X is adjacent to it because it's next to it, but it's not the hypotenuse. And it actually doesn't matter which you find first. So do you want to find the opposite side first or the adjacent side first? Adjacent. Okay, so since we're going to find the adjacent side first, we're going to use cosine because we have the hypotenuse and we don't know the adjacent. So since we know an angle, we're going to do cosine of 62. And again, I picked 62 to use. You could also use 28, but I picked 62, so that's why I circled the A. So since I picked 62 to use, make sure you use that in your cosine. So cosine of 62 equals, we don't know the adjacent, so X is going to go on top. And then we have the hypotenuse, so 10 goes on the bottom. And then we just need to solve. So how do we solve? Yeah, times there. We're going to take 10 times cosine of 62, which is 4.7. So now we know that this side is 4.7. So the only thing left is finding that side, and this is where I actually have a decent choice. If you want to use SOHCAHTOA again, you could. The only thing we need to switch is now we're finding opposite instead of adjacent. So instead of using cosine, you could use sine. So you're more than welcome to use SOHCAHTOA again. Or, since we have two sides, we know two sides of the right triangle, what could we use?
A squared plus
A squared plus B squared equals C squared. So when you have this choice, it's actually either one of them is not too bad to find. You could use SOHCAHTOA or you could use Pythagorean theorem. So which one do you want me to use?
the A squared one.
Yeah. So I'll use A squared plus B squared equals C squared. So we know 10 is the hypotenuse, so 10 has to go in for my C, so I'm going to put that in there. And then I found my one side is 4.7. So I'm going to use the letter Y because that's what I have labeled as the side I don't have missing. So Y squared plus 4.7 squared. And then we just need this one. Don't know what 4.7 squared is. So 22.1. 37.91. And then we just need to take the square root. Not quite as nice as the square root I had to do earlier. So 8.8. Do we need to do another example? Or do you think we're good? I'll go ahead and give you the worksheets. I might go ahead and go through them and put them up on the board. That way if you want to fill them out, you can, or if you want to do them on your own. But like I said, it's really nothing new. It's just taking everything we've done and putting it together. So we don't have an exit here. There is just a little worksheet, and it just has 4 questions on it. So there's 4 triangles for you to solve. Looks like 3 of them have an angle on a side, so like this last example, and 1 of them has 2 sides. So always have 3. Yep, always will have. Because you start with 3 things, and then you have to find